The signal in the silence, opening, the age-old question. For thousands of years, humans have gazed at the night sky with a sense of awe and curiosity, wondering about the mysteries hidden among the stars. From ancient astronomers charting constellations to modern scientists launching telescopes into orbit, one question has echoed louder than all the rest. Are we alone? We've pondered it in myths and in science fiction, searched for it in radio waves and distant star systems. We've asked it with hope, fear, and wonder. But despite our greatest efforts, we've never found a definitive answer. Until now. Roughly 120 light-years from Earth, orbiting a cool red dwarf star in the constellation of Leo, lies a planet that's beginning to rewrite everything we thought we knew. A world so unusual, so curiously familiar, that scientists around the globe are pausing, rethinking, and asking if this is the moment we've all been waiting for. Its name is K2-18B. And thanks to the incredible capabilities of the James Webb Space Telescope, we may have just glimpsed the first unmistakable signs of life beyond our own world. The discovery, reading the light of another world, what we found isn't science fiction. It's science, pure, powerful, and revolutionary. In the atmosphere of K2-18b, the James Webb Space Telescope detected the presence of water vapor. That alone is significant. But the readings didn't stop there. Methane, carbon dioxide, and something truly extraordinary, dimethyl sulfide. On Earth, dimethyl sulfide, or DMS, is a compound that's produced almost exclusively by living organisms, particularly microscopic marine life called phytoplankton. It's not something we associate with lifeless rocks or random chemistry. It's a biosignature, a chemical clue that suggests life. Even more astonishing, scientists identified another molecule, dimethyl disulfide, or DMDS. Another compound closely tied to organic activity, especially in Earth's oceans. Together, these molecules appeared in the same region of the planet's atmosphere. Their presence, under the right conditions, becomes more than chance. It becomes a pattern. And patterns like these? They point to life. Dr. Nikku Madhusudan, the Cambridge astrophysicist who led the study, called the detection of DMS and DMDS a watershed moment in our quest to find life elsewhere in the universe. Because for the first time, we're not just imagining alien worlds that might support life. We're seeing molecular evidence that may already be created by it. The planet, a Hycean world, K2-18b, isn't a typical rocky exoplanet like Earth or Mars. It's something much stranger and more promising. Scientists call it a Hycean world, a planet with a vast ocean beneath a thick hydrogen-rich atmosphere. It's about 2.6 times larger than Earth and nearly 9 times as massive. On paper, that makes it more like Neptune than Earth. But the similarities don't stop at size. K2-18b orbits in what astronomers call the habitable zone, a region around its star where temperatures could allow liquid water to exist on the surface. And where there's liquid water, there's potential for life. Unlike the cold, dry deserts of Mars or the violent gas storms of Jupiter, this planet may have an ocean covered by a thick blanket of hydrogen gas that acts like a thermal jacket. This protective atmosphere keeps the planet warm, shields it from harmful radiation, and could create a stable environment, one similar, in many ways, to the early conditions on Earth billions of years ago. If true, K2-18b could be more than a planet, it could be a cradle. A place where life is not just possible, but perhaps already underway. The question of life, ancient echoes. So what might life look like on a planet like K2-18b? Some scientists believe it could resemble Earth during its earliest chapter, a time before plants, animals, or even multicellular life. A world of microscopic marine organisms floating silently in vast alien oceans, feeding on sunlight from a red sun. Others imagine something more complex, filter-feeding organisms drifting slowly beneath the waves, basking in filtered starlight. Creatures adapted to high atmospheric pressure and low gravity. Possibly even life that's capable of limited movement within the dense upper clouds. In this view, K2-18b isn't just biologically active, it could be evolving. Not a mirror of Earth today, but of Earth as it once was, when photosynthesis had just begun to change the atmosphere, and when life stirred in the oceans before it ever crawled onto land. Maybe that's what we're watching now. Not just life on another world, but its first awakening. The turning point. What makes this discovery so powerful is that it isn't built on speculation, it's built on data. We're no longer just dreaming of alien oceans. We're detecting their chemistry. We're no longer just hoping to find life. We're identifying its possible byproducts. This isn't fiction. It's fact. And it's reshaping not just how we view the cosmos, but how we view ourselves. Because if life can begin on a world so different from Earth, richer in hydrogen, lit by a red dwarf sun, surrounded by deep clouds and strange tides, then life may be more adaptable, more varied, and more common than we ever dared believe. And if we are not alone, then we are not the center. We are not the first. We are not the only. We are just part of something. Whispers from a living universe, the contact debate. Should we speak? With the discovery of possible signs of life on K2-18B, humanity now faces a profound question. Should we try to make contact? Some scientists, like physicist Mark Buchanan, warn against it. What if we disrupt a fragile alien ecosystem, or worse, attract attention from something far more advanced than us? Others, including Avi Loeb, argue the opposite. Any intelligent life would have already detected us, our signals, satellites, and probes. If they haven't acted yet, perhaps they're simply observing. Or choosing silence. Still, even if we decide to reach out, any message would take 120 years to arrive, and another 120 to return. We wouldn't live to see the reply. So the real question isn't just can we send a message. It's whether, knowing what we now know, we should. The world reacts. Awe and urgency. When Webb's findings became public, the world reacted instantly. News outlets ran breaking coverage. Social media exploded with hashtags like hashtag K2-18B and hashtag AlienOcean. For once, headlines weren't about politics or crisis, but about the possibility of life beyond Earth. NASA, ESA, and even private space firms accelerated plans for deep space missions. Students flooded classrooms with questions. Universities launched emergency reviews. K2-18B didn't just capture scientific attention, it rekindled humanity's shared sense of wonder. The silence, Fermi revisited, but amid that wonder, an unsettling question returned. If life is out there, why is it so quiet? The Fermi paradox gained new urgency. Maybe intelligent civilizations rise and fall before they can make contact. Maybe the path from microbe to mind is incredibly rare, or incredibly risky. Or perhaps life is everywhere, but chooses silence. If K2-18B holds only microbes, it's a world in its infancy. But if we find complexity, structures, systems, even primitive intelligence, then silence may not be absence. It may be a message. You are not alone. You are not the first. But be careful what you say next. Biology Rewritten. The shape of alien life, K2-18B is also challenging how we define life itself. On Earth, life depends on oxygen, carbon, water, and sunlight. But K2-18B's atmosphere is hydrogen-rich, its sun a dim red dwarf. Could alien organisms breathe hydrogen? Could photosynthesis evolve in infrared light? Biologists are now studying Earth's extremophiles, creatures that live in boiling acid, deep sea vents, radiation, even vacuum. Once considered rare exceptions, they might now be blueprints for alien life. And a disturbing thought follows. What if we've already encountered alien biology, on meteorites, in strange signals, and failed to recognize it? Not everything alive will look alive to us. A new perspective, Earth in context. Before K2-18B, we viewed Earth as special. Now, we must see it as one world among many. Psychologists warn of cosmic trauma, the shock of not being unique. Religions are reconsidering origin stories. Governments are assessing global impacts. But in classrooms, labs, and imaginations, something brighter is happening. A generation is growing up knowing Earth may not be alone. That life, in all its forms, could be the rule, not the exception. Final reflection. The mirror. When the James Webb Space Telescope stared into the clouds of K2-18B, it didn't just find strange chemistry. It found a mirror. Not of who we are now, but of who we once were. Or who we might become. For centuries we believed we were the only light in a vast, dark sea. But K2-18B whispered something different. Life is not rare. Life is not silent. It is out there. Becoming. Evolving. And now we're not just asking if we're alone. We're asking, who else is out there? When will we meet them? And are they already watching us? Closing call to action. This is no longer just a story about a planet. It's a story about us. About curiosity. About humility. About our place in something unimaginably vast. Because sometimes, the universe doesn't shout. It waits.